In 1888, a seemingly routine anatomical drawing from a prestigious medical institute was catalogued and carefully studied for decades. The subject of this meticulous illustration was an organ that, as it would turn out, existed in no human body. This peculiar document would become one of the most enduring mysteries in the history of medical science, a phantom that haunted textbooks and lecture halls for nearly a century. The question at the heart of this mystery is deceptively simple. How could a drawing of a non-existent human organ become a cornerstone of medical illustration, fooling generations of experts who prided themselves on their careful observation and scientific rigor? This was not a simple case of artistic license or imaginative embellishment. This was a meticulously rendered anatomical drawing, complete with detailed labels and cross-references that depicted something fundamentally impossible. The mystery of this phantom organ is the key to understanding the profound intellectual blind spots of 19th-century science, and how authority and reputation could override the most basic principles of scientific verification. The subject of the drawing was a complex, fibrous structure that appeared to be deeply embedded within the human torso. The principal illustrator was Oakley, a respected anatomical artist at the Academy of Medicine, London, an institution known throughout Europe for its contributions to medical education and research. Oakley had built a reputation over 2 decades for producing anatomical illustrations of exceptional accuracy and detail. His work was featured in major medical texts and used in teaching hospitals across Britain. The era in which Oakley worked was one where direct observation was the primary tool of scientific investigation, and verification was a slow, painstaking process that could take years or even decades. Photography was still in its infancy, and the preservation of anatomical specimens was a challenging and imperfect art. The drawing itself was accepted almost immediately by the medical establishment, reproduced in textbooks, and quietly became a fixture within the medical curriculum. The conflict at the heart of this story is not the existence of the organ itself, but rather the persistence of error. How did such a fundamental mistake survive for so long in an institution dedicated to the pursuit of truth? The answer reveals much about the nature of scientific authority and the human tendency to trust reputation over evidence. Oakley claimed the drawing was sourced from a dissection performed by the renowned, yet controversial surgeon Daxton at the Royal Infirmary, Edinburgh. Daxton was a figure who commanded respect and fear in equal measure. His surgical techniques were considered revolutionary, though his methods were often questioned by more conservative members of the medical establishment. He had a reputation for making bold claims about his discoveries, and his willingness to challenge conventional wisdom made him both admired and distrusted. The phantom organ was allegedly found in a patient designated as Taddeo, a factory worker from the Midlands who had died of an unrelated respiratory illness in the winter of 1887. According to the documentation that accompanied the drawing, Taddeo had been brought to the Royal Infirmary, Edinburgh for treatment of severe pneumonia, but had died within days of admission. The organ itself was given the name Leman fibratus in the official documentation. It was described as a dense network of vascular and nerve tissue situated deep within the torso, positioned in a location that seemed to defy the known architecture of human anatomy. The key detail that should have raised immediate alarm was that its structure violated every established principle of human physiology. The vascular connections depicted in the drawing were anatomically impossible. The nerve pathways showed connections that could not exist in any known vertebrate. Yet the drawing was accepted, catalogued, and distributed. There were early doubts, though they were largely forgotten or ignored. Sage, a relatively obscure anatomist working at a provincial medical school, published a brief skeptical letter in the Journal of Clinical Anatomy in 1891. Sage pointed out several glaring inconsistencies in the drawing, particularly the impossibility of the vascular connections shown in Oakley's illustration. Sage noted that the arrangement of blood vessels would have required a complete reorganization of the major arteries and veins in the human torso, something that could not occur in any living organism. The letter was polite but firm, and it raised questions that should have prompted immediate investigation. Instead, it was largely ignored by the medical establishment, dismissed as the petty complaints of a minor figure seeking attention. The drawing achieved widespread acceptance through a combination of institutional prestige and personal influence. This was a time of intense competition among medical schools, each eager to establish itself as the leading authority in anatomical research. The Academy of Medicine London was particularly eager to showcase new findings that would cement its reputation as the premier medical institution in Europe. The drawing was championed by Apollo, a powerful and influential professor who had trained a generation of surgeons and anatomists. Apollo was a close colleague of Daxton, and he vouched personally for the integrity of both Daxton and Oakley. Apollo's endorsement silenced most open questioning, as few junior colleagues were willing to challenge someone of his stature and influence. The drawing was included in the textbook of regional anatomy in 1895, a comprehensive work that became the standard reference for medical students throughout Britain and much of Europe. This inclusion was the mechanism of error propagation. Once the drawing appeared in this authoritative textbook, it ceased to be a questionable illustration and became accepted fact. Medical students memorized the limen fibratus along with the liver, kidneys, and spleen. They learned its supposed function, its location, and its relationship to surrounding structures. Professors lectured on it with confidence, and anatomical models were even created to help students visualize this phantom structure. The central controversy that should have emerged but did not was the complete lack of physical evidence beyond the original drawing. No other dissection, whether performed by Daxton or anyone else, ever produced another example of the limen fibratus. This should have been an enormous red flag. In modern science, a finding that cannot be replicated is immediately suspect. But in the late 19th century, the standards were different. A single observation by a trusted authority could become established fact, particularly if it was supported by a detailed illustration from a respected artist. The professional rivalry and pressure on Daxton to deliver groundbreaking findings may have played a role in the acceptance of this questionable discovery. Daxton had made several other anatomical claims that were later proven false, but his reputation protected him from serious criticism. The quiet discovery of the error began in 1968, 8 decades after the original drawing was created. Lawson, a doctoral student at the National Anatomical Registry, was working on what seemed like a straightforward project. Lawson was compiling a comprehensive list of documented human anatomical anomalies, those rare variations in structure that occur in a small percentage of the population. The project required systematically cross-referencing all known anatomical illustrations with modern medical imaging and cadaver studies. Lawson was meticulous and thorough, checking each illustration against MRI scans, CT images, and direct physical examination of preserved specimens. The moment of recognition came when Lawson was reviewing illustrations of the torso region. The limen fibratus appeared in the 1895 textbook and in several derivative works published in the early 20th century, but nowhere else. Lawson searched through the registry's extensive collection of preserved specimens, looking for any physical example of this structure. Nothing existed. Lawson consulted modern medical imaging databases, searching thousands of scans for any hint of the fibrous network depicted in Oakley's drawing. Again, nothing. The limen fibratus existed only on paper. There was no physical specimen, no second-hand account from any other anatomist, and no physiological possibility that such a structure could exist. The drawing was an anatomical ghost, a phantom that had haunted medical education for decades without anyone noticing its impossibility. The question that consumed Lawson was not just that the error existed, but why such an obvious error had persisted for nearly 80 years. The answer revealed something fundamental about the nature of scientific authority. The medical community had valued the authority of a great institution and the reputation of respected individuals over repeated, meticulous individual observation. Once the drawing had been endorsed by figures like Apollo and included in a standard textbook, it became almost immune to criticism. Junior researchers who might have noticed the inconsistencies were reluctant to challenge established authorities. Senior researchers simply accepted what they had been taught, never thinking to verify the existence of a structure that appeared in every major anatomical text. Lawson's findings prompted an official investigation by the National Anatomical Registry, though the investigation was conducted quietly to avoid embarrassment to the institutions involved. The investigation was led by Kean, who served as the ethics chair for the registry. Kean assembled a small team of historians and anatomists to examine the original documentation surrounding the 1888 drawing. The team gained access to the personal archives of both Daxton and Oakley, documents that had been stored but never carefully examined. The climax of the investigation came when the team discovered a small notation in Oakley's personal sketchbook. Next to a preliminary version of the famous drawing was an asterisk, and in the margin was a brief note referencing a sketch made during a dissection of a non-human primate conducted a week before the alleged dissection of Taddeo. The note indicated that Oakley had been particularly impressed by the complexity of a fibrous organ found in the primate specimen, an organ that had no equivalent in human anatomy. The complexity and structure of this non-human organ was strikingly similar to the limen fibratus depicted in the final drawing. The shocking discovery was that the 1888 drawing was a composite and inadvertent combination of two separate observations. Oakley had apparently confused or combined elements from the primate dissection with the human dissection, creating a hybrid illustration that depicted a structure that could not exist in any human body. This was not deliberate fraud or malicious deception. It was a simple mistake, an intellectual slip during what Oakley's own notes described as an exceptionally busy period. He had been working on multiple illustrations simultaneously, rushing to meet deadlines imposed by the Academy of Medicine London. The error was a minor technical mistake in the studio of a busy medical illustrator, but it had been elevated to a major scientific falsehood by the institutional weight and professional authority placed upon it. The limen fibratus was formally removed from all anatomical texts in 1971, 83 years after its creation. The conflict was resolved not by exposing a fraud, but by classifying the drawing as a composite artifact. The official statement from the National Anatomical Registry described it as a cautionary tale about the dangers of over-reliance on single observations, no matter how brilliant or detailed they might appear. The statement emphasized that scientific knowledge must be built on reproducible evidence, not on the authority of respected names or prestigious institutions. The story of the limen fibratus is not a story of deliberate malfeasance or calculated deception. It is a story of the slow, methodical process of scientific verification, and how that process can be undermined by human factors like reputation, authority, and institutional prestige. The drawing survived for so long precisely because it was a product of high authority. Oakley was respected, Daxton was famous, Apollo was influential, and the Academy of Medicine London was prestigious. Together, these factors created an environment where the drawing was inherently resistant to critique. Junior researchers who might have questioned it lacked the standing to challenge such established authorities. Senior researchers simply accepted what they had learned, never thinking to verify something that appeared in standard textbooks. The women involved in uncovering this error deserve particular recognition. Mira, a research librarian at the Royal Infirmary, Edinburgh, provided crucial assistance to Lawson by locating obscure 19th-century correspondence that helped establish the timeline of events. Peyton, an archivist at the Academy of Medicine London, discovered additional sketches in Oakley's personal papers that confirmed the composite nature of the drawing. Hattie, a medical historian, provided essential context about the competitive pressures faced by medical institutions in the late 19th century. Astrid, a comparative anatomist, identified the specific primate species from which the non-human organ likely came. Brin, a medical ethicist, helped frame the official statement that accompanied the formal retraction of the drawing from medical texts. Winter, a medical illustrator herself, analyzed Oakley's technique and confirmed that the type of error he made was entirely consistent with the working methods and time pressures of 19th-century medical illustration. Allen, a science journalist, wrote the first comprehensive public account of the discovery, bringing the story to a wider audience and prompting discussions about scientific authority and verification that continue to this day. The real lesson of the Lyman fibratus extends far beyond the specific error itself. It demonstrates that science must always be a democracy of evidence, not an oligarchy of famous names. Authority and reputation have their place in scientific discourse, but they can never be allowed to override the fundamental requirement for reproducible evidence. The medical community of the late 19th century had allowed institutional prestige and personal influence to substitute for rigorous verification, and the result was an error that persisted for generations. Modern science has developed better safeguards against such errors, but the human factors that allowed the Lyman fibratus to persist still exist. The pressure to publish groundbreaking findings, the reluctance to challenge established authorities, the tendency to trust prestigious institutions. These are all still present in contemporary scientific culture. The story serves as a reminder that every generation of scientists must remain vigilant against these tendencies, constantly questioning and verifying even the most established facts. The phantom organ of 1888 imposed a long silence on anatomical truth, a silence that was finally broken not by a dramatic revelation, but by the patient, methodical work of researchers like Lawson, who were willing to question what everyone else simply accepted. This episode represents a victory for modern, rigorous, evidence-based science over the older model of authority-based knowledge. It shows that scientific progress depends not just on brilliant discoveries, but on the willingness to carefully verify and occasionally correct the work of previous generations, no matter how respected those earlier scientists might have been.